Hello everyone, my name is RiteshVerma and today I will be presenting on Liquid Galaxy front-end ecosystem, focusing on progressive web app, Project Fugu and the Go Web Store. This presentation is not just about technology individually. It is about how modern web technology comes together to build, enhance and distribute front-end applications for Liquid Galaxy, which is a highly immersive and multi-screen system. In this presentation, we will understand why frontend is critical for Liquid Galaxy, why PWAs are preferred application format, and how Project Fugu extend web capabilities, and how the Go web store completes the ecosystem. Let's start by setting the context. Till now, when most people hear the name Liquid Galaxy, they immediately think of it as a visualization system, something that shows Google Earth on the multiple screen or displays immersive visual content. And yes, this is true, but that is only one part of the story. When we look at the Liquid Galaxy from front-end perspective, it is much more than just visualization. Liquid Galaxy is actually a web-driven immersive platform. What does that means? It means the system is designed in such a way that web technologies sit at the center of how user interact with it. Liquid Galaxy works like a multi-screen web runtime. Instead of thinking of each screen or a machine as a separate system, we treat the entire setup as one large web-based environment. Now, in traditional system, applications are installed as a heavy native software on every single machine. This create a problem like each node needs manual setup, updates are slow, and compatibility becomes an issue. Liquid Galaxy avoid this by taking a browser-first approach. Applications are delivered using browsers and web applications, not as a native binaries. This means the browser becomes a runtime environment for the entire system, and this is extremely important. Why? First, web applications are very easy to deploy. You don't need a complex installation step. You just load the app and it works. Second, web apps are scaled very well across the multiple screens. In Liquid Galaxy, we are not dealing with one screen. We are dealing with many screens working together. Web technology are naturally good at handling distributed layout and the synchronization view. Third, centralized control become possible. Instead of controlling each machine separately, we control the entire Liquid Galaxy setup from a single web interface. So, rather than writing a platform, a specific application like one app for Linux, another for something else, we can write one single web application. And that one web application can control interaction, trigger visual changes, synchronize content, and communicate with all screen in the cluster. This is a very powerful idea. This web first design is not accidental. It is what make Liquid Galaxy future ready. Because once your platform is web driven, you can easily adapt modern front end frameworks, progressive web apps, and advanced browser APIs. This is exactly why Liquid Galaxy is a perfect match for the modern front-end technology, which we will explore in the next slides. Now the question is, why does front-end matter so much in Liquid Galaxy? To understand this, we need to think about how people actually use Liquid Galaxy. Liquid Galaxy is not a passive system. Users don't just stand there and watch something playing on the screen. Liquid Galaxy experience are very user interaction heavy. Every meaningful action that happens in Liquid Galaxy start from user's input. For example, a user navigate from one location to other, control timelines during storytelling, or switching layers or dataset. All of this happens in real time. And how do users perform these actions? They don't do it directly on the backend or on any system. They do it through controller, dashboard, or interactive tools. And this controller and dashboard are not are a pure front-end component. So in Liquid Galaxy, the front-end not just a visual layer; it is primary interaction layer. If a front end is smooth and responsive, if the front end is smooth and responsive, the experience feels immersive and powerful. But if the front end is slow, unresponsive, or confusing, the entire experience breaks. Now imagine this situation. You want to update a controller a UI or just to fix a small issue. If the front end is built using traditional application model, you may need to rebuild the app or reinstall it on multiple machines or just restart the system. This is not the practical for the multi-screen immersive system. That's why front end in Liquid Galaxy need to be fast, flexible, and scalable. Traditional app models struggle with this, and they are usually slow to update and hard to scale. Liquid Galaxy needs a front-end approach where changes can be deployed quickly, interface can evolve easily, and new interaction pattern can be added without breaking the system. This is exactly why front-end becomes a core pillar of the Liquid Galaxy. And once we accept that front-end is central to the experience, it naturally leads us to the next question. How do we design and manage front-end application in a scalable way? That question leads us directly to the need for a front-end ecosystem, which we will look at in the next slide. Earlier, many Liquid Galaxy applications were built as traditional applications. This means they are usually installed directly on each machine and that are tightly coupled to operating system and need updated manually. At first, this approach worked, but as Liquid Galaxy system become larger and more widely used, serious limitations start appearing. The first major issue was complex installation. In Liquid Galaxy setup, you don't have just one machine. You must have five or seven or even nine machines working together. Installing an application on each node separately takes time and effort. If something goes wrong on one machine, the whole system can behave unpredictably. The second issue was platform dependencies. Traditional application often depends on a specific operating system version, specific libraries, even a specific configuration. This makes maintenance difficult, especially in open source community driven environment like Liquid Galaxy. The third and most painful issue was slow and manual updates. Imagine you fix a small bug or add a minor feature. You have to rebuild the app, deploy it again, or even update every machine manually. Updating seven or six machines one by one is simply not scalable. As Liquid Galaxy system grew in number and complexity, this approach clearly did not work anymore. So, what is the solution? Solution is the web first architecture. In a web first approach, applications are centralized, updates are instant, and deployment is simplified. Instead of installing apps on every node, you host the app once and access it through the browser. Modern browsers are extremely powerful. They support advanced graphics, offline capabilities, background tasks, and secure APIs. By using a browser as runtime, Liquid Galaxy can reduce the system complexity, improve maintainability, enable faster innovation. This shift from a standalone application to a front-end ecosystem was a very important step. And once you have a front-end ecosystem, you also need a proper way to distribute and manage application. This is where the Go Web Store comes in, which we will explore next. Now that we understand why Liquid Galaxy need a front-end ecosystem, let's talk about one of the most important component of that ecosystem. That is the Go Web Store. The Go Web Store is officially front-end app distribution platform for Liquid Galaxy. In a very simple word, you can think of it as an app store. But instead of a mobile app, it is basically designed for Liquid Galaxy web applications. Its the main goal is to solve a very practical problem. How do we distribute, discover, and manage front-end application in a clean and scalable way? Before the Go Web Store, developer often had to share applications links manually and explain setup steps repeatedly and handle the deployment separately for each system. This approach does not scale well, especially in global open source community. The Go Web Store fixed this by acting as a central catalog for applications. All Liquid Galaxy front-end applications can be listed in one place. This make it easy for a user to discover available apps and developer to showcase their works and the community to grow together. Another very important aspect is that Go Web Store is community driven and open source. This means anyone can contribute, anyone can improve existing apps, and the ecosystem does not depend on a single organization. This align perfectly with open source philosophy of Liquid Galaxy and programs like Google Summer of Code. The Go Web Store is optimized for immersive environment. It is not a generic App Store. The application listed here is designed with Liquid Galaxy's multiple screen immersive setup in mind. The things like controller, dashboard, and presentation tool are built to work smoothly with Liquid Galaxy system. Now, let's talk about distribution, which is where the Go Web Store become really powerful. Instead of manually deploying application on each Liquid Galaxy setup, developer can simply publish their apps to the Go Web Store. Once published, Liquid Galaxy system can easily discover these apps. Updates can be rolled out quickly and maintenance become much simpler. This completely resolves the need for the complex manual deployment. As a result, the entire front-end ecosystem becomes organized, where apps are structured and discoverable and scalable, work for many systems and user, and developer friendly, which is easy to build, publish, and maintain. So, the Go Web Store is not just a website. It is the key infrastructure component that enables the modern Liquid Galaxy front-end ecosystem. The next slide, we will look at what kind of application actually live inside the Go Web Store and how they are used in real scenarios. Now that we understand what a Go Web Store is, the next natural question is what kind of application actually live inside it. The Go Web Store is not meant for just and any random web apps. It is focused especially on applications that enhance the Liquid Galaxy experiences. The first category you will mainly find is controller and remote interface. These are the applications that allow users to control navigations, um, move between locations, and trigger actions on Liquid Galaxy screen. Often, these controllers run on laptops, tablet, or even mobile devices, and they communicate with Liquid Galaxy system in real time. The second category is the visualization tool. These tools help in displaying data visually, showing layers, maps, or timelines, and enhancing how information is presented across multiple screens. They are especially useful in education, research, and data-driven storytelling. The third category is presentation and storytelling app. Liquid Galaxy is widely used for storytelling, whether it is educational tours, project demonstration, interactive presentation, or something like that. This app help presenters control the flow of content, timing, and visual, which make the experience smooth and immersive. The fourth category include a utility and system interaction apps. These are supporting tools that help with system interaction, monitoring, configuration, or supporting workflow. They are not always be visible to end user, but They are very important for a smoother operation. Now, there is one common thing across all these applications. All of them are designed to run as web app or a progressive web app. This is a very deliberate design choice. Why is this important? First, there is no platform lock-in. The same app can run on different devices and the system without a modification. Second, there is no need for native installation on each Liquid Galaxy node. This saves time and reduces complexity. The third, update becomes very easy. When an app is updated in Go Web Store, all the systems can access the latest version immediately. This makes the entire ecosystem easier to maintain, easier to scale, and easier for a new developer to contribute. Now that we have mentioned progressive web apps multiple times, it is important to clearly understand what is progressive web apps actually are. So in the next slide, let's take a closer look at progressive web apps. Now that we have seen that most application in Go Web Store are built as PWAs, let's clearly understand what progressive web applications actually are. Progressive web apps or PWAs are a web application with native behavior. At their core, they are still web apps. Um, they are built using a standard web technology like HTML, CSS, and JavaScript. This is nothing special or anything about the technology stack. Any developer can build a PWA, but what makes PWA different is how they behave. Unlike a traditional web page, PWS behaves much more likely as a native application. Let's break this down. First, PWAs can be installed on device. This means a user can add a PWA to their home screen or desktop. Once installed, it looks and feel like a regular app, not just a browser tab. Second, PWAs can work offline or in a poor network condition. Using caching and background logic, a PWA can load even when the internet is slow, continue working without connectivity, and provide a smooth user experience. This is very important in a real world environment where connectivity may not always be perfect. Third, PWAs feel fast and responsive. They are designed to load quickly and respond instantly to the user input and behave smoothly, just like a native app. User don't feel like they are using website. They feel like they are using a proper application. Fourth, PWAs can run directly in the browser. There is no need for App Store approval or any platform specific build and any separate binaries. The browser becomes the runtime. This means this gives the developer a lot of flexibility. So when we put all these together, PW gives us best of both worlds. From website, we get development, easy deployment, and cross-platform support. From the native side, we get installability, offline support, and performance. This combination is exactly what modern systems need. And this is why PWAs are not just a trend, they are a practical solution for building a scalable application. Now, let me understand what a PWA are. The next logical question is, why are PWAs especially suitable for Liquid Galaxy? Let's explore in the next slide. Now that we understand what progressive web apps are, let's see why they are such a perfect fit for Liquid Galaxy. Liquid Galaxy has a very unique architecture. It is not a single device system, it is a distributed and multi screen setup. PWAs match this architecture almost perfectly. First, one PWA can control multiple screens. Instead of running different applications on each screen, a single PWA can act as a control layer for the entire Liquid Galaxy cluster. This makes coordination much easier and more reliable. Second, PWAs can run without native installations on each node. This is extremely important. In a traditional setup, every machine would require its own installation and configuration. With PWAs, the application simply run in the browser. This removes platform-specific issues, installation complexities, and maintenance overhead. Third, the PWAs can be updated instantly across the entire cluster. If you make a small improvement or fix a bug, you don't need to install anything. Once the PWA is updated, all the Liquid Galaxy system can immediately access the latest version. This is extremely powerful, especially for the live environment and demos. Let's talk about use cases. PWA are ideal for controllers that manage navigation and interaction. Dashboard that display information and the status, and a real-time interaction tool that respond instantly to user input. These are exactly the kind of application Liquid Galaxy depends on. And because the Liquid Galaxy itself is a distributed system, PW naturally fit it to the model. They are designed to work across devices, screens, and environments without adding unnecessary complexities. However, there is one important point to understand. While PWA are very powerful, they are not enough on their own. For deeper system access, like interacting with files, devices, or system feature, we need something more. That is where Project Fog come in. And in the next slide, we are look at what Project Fog is and why it matters. Before we go deeper into advanced topic, let's take a moment and understand the core building block of a progressive web app. Progressive web app is not created by using a single framework or any single library. Instead, it is built by combining a few key web standards. Every PWA relies on four main building blocks. The first one is a web app manifest. The web app manifest defines identity of the application. It tells the browser about the app's name, icon, theme color, and how the app should appear when installed. This is what allow a web app to be installed on device and behave like a native app. The second building block is service workers. Workers run in the background and separate from the main UI. They handle things like caching resources, enabling offline uses, improving performance. This is what allows PWA to work even when the internet connection is weak or unavailable. The third building block is HTTPS. This is important because it ensures secure communication, it protects user data, and it also allows access to advanced browser API. Without HTTPS, many powerful PWA features simply uh, will not work. The fourth building block is the responsive user interface. PWA are designed to run mobile, tablet, laptop, or large displays. A responsive UI ensure that the same application works smoothly across different screen size and devices. When we combine all this building block, we get an application that are reliable, secure, and scalable. These building blocks are the foundation of PWAS. Now, that we understand this foundation, the next step is to see how we can extend these capabilities even further. That is where the project Fugu comes in. Uh, we will explore next. Let's talk about something that takes web application to the next level. That is Project Fugu. Project Fugu is an initiative that expand what web applications can do. Traditionally, web applications are quite limited when it comes to the system access. They could display content and handles user interaction, but they had a very restricted access to the operating system. For example, things like the direct file access, device level interaction, or background task were mostly possible in native applications. Project Fugu changed this situation. The idea behind the Project Fugu is to bring native capabilities to the web. while still maintaining the security and user control. It does this by safely exploring it does this by safely exposing the system level APIs to the web applications. This is very important point. Project Fugu does not give unrestricted access to the system. Instead, it follow a permission based and secure approach. Users are always aware of what access an application is requesting, and browsers enforce strict security boundaries. Because of this, developer can build a powerful real-world web application without compromising the safety. With Project Fugu, web apps can interact more deeply with systems, handle complex workflow, provide experiences that were earlier possible only with native apps. The main goal of the Project Fugu is exactly very simple. It is to close the gap between the web apps and the native apps, not by replacing the native apps, but by making web app capable enough for serious and productive label use case. This is extremely important for advanced Liquid Galaxy application. Liquid Galaxy need rich interaction, device integration, and smooth performance. Project Fugu enable PWAs to meet these requirements. In the next slide, we will look at some key Project Fugu APIs and see how they are especially useful in a Liquid Galaxy ecosystem. Now that we understand what Project Fugu is, let's look at some specific Project Fugu APIs that is especially useful for Liquid Galaxy. Not every API is relevant for every use case, but Liquid Galaxy, being an impressive and interactive system, benefits a lot from certain capabilities. First important API is file system access. This API allow web application to read and write files securely. Earlier web apps that very limited access to the local files. With file system access, applications can load a dataset, save configuration, and manage files in a controlled way. This is very useful for visualization tools and data-driven applications in Liquid Galaxy. The second API is badging API. Badging API allow application to show status indicator. For example, it can show active status, notification, and progress indicator. In Liquid Galaxy setup, this can be useful for controller or a dashboard to indicate system state or any background progress. The third API is the web share. Web share allows application to easily share content using system native sharing mechanism. This is useful when user want to share links, share data, or trigger collaboration workflow. The next category is hardware and device access. Project Fugu enable controlled access to the device such as connected hardware, input device, and sensors. This allow a web application to interact more naturally with system environment. The last category is background task and sign. This allow PWA to perform operations in the background, sign data when connectivity improves, and keep the application state updated. This is very important for maintaining a smooth user experience in an impressive setup. When we use these API together, the PWAs gain the ability to access the file securely, interact with devices, and run background operation. This combination unlock advanced PWA experiences. As a result, web app become powerful enough for impressive system like Liquid Galaxy. In the next slide, we will see how all these pieces PWAs, Project Fugu, and the Go Web Store works together as a complete ecosystem. Now that we have looked at each part individually, let's take a step back and connect all the dots. This slide shows the front-end ecosystem flow for the Liquid Galaxy. At the center of the ecosystem are Progressive Web App or PWAs. PWAs act as application format. They define how the applications are built using a standard web technology while still offering features like installability, offline support, and performances. So, PWAs are foundation. On the top of PWAs, we have a Project Fugu. Project Fugu provide the advanced capabilities that PWAs need in real-world scenarios. It allows web application to access files securely, interact with devices, and run background tasks. Without Project Fugu, PWAs would remain limited to the basic functionalities. With Project Fugu, they becomes powerful production-ready applications. The third major component is Go Web Store. Go Web Store handles distributions and discovery. It answers important questions like where do developers publish their apps? How do users discover available applications? And how are the update managed? By acting as a central catalog, the Go Web Store make ecosystem organized and scalable. Now, when we put this together as PW as the format, Project Fugu as the capability layer, Go Web Store as the distribution layer, we get something very powerful. That is web app for the immersive system like Liquid Galaxy. And this is not just a theoretical model. This architecture is practical, scalable, and maintainable with open source friendly ecosystem. It is support real world use case, community contributor, and long term evolution of the Liquid Galaxy platform. In the next slide, we will look at this ecosystem from developer point of view and understand the workflow for building and developing applications. Now, let's look at the front-end ecosystem from developer point of view. One of the biggest strength of this ecosystem is that developer workflow is very simple and clean. There are no unnecessary step, no complex tooling requirement, and no specific complications. The first step is to build a web app or a progressive web app. Developer can use familiar web technologies like HTML, CSS, JavaScript, and modern front-end framework if needed. There is no need to learn a completely new stack. If you know web development, you can start building for Liquid Galaxy. Second step is to enhance the application using a Project Fugu APIs. This is where application become more powerful. Developer can selectively add file system access, device interactions, background tasks only when needed. This keeps the application lightweight while still allowing the advanced feature. The third step is to publish the web applications via Go Web Store. Instead of sharing links manually or managing custom development, developer can publish their app to the centralized platform. This makes the app discoverable, easy to maintain, and easy to update. Once published, the application becomes part of Liquid Galaxy ecosystem. The final step is to deploy. Deployment is almost instant. Liquid Galaxy setup can simply access the web application from Go Web Store and start using it immediately. There is no complex installation, no pre-machine setup, and no need to, and there is no platform dependencies. Uh, this is what build once, deploy everywhere really means. This workflow is modern, efficient, and scalable, very friendly for open source contributor. And this is exactly the kind of workflow needed for a platform like Liquid Galaxy, which is used by different organizations like the students and developer across the world. In the final slide, we will quickly summarize everything we have learned today. First, we understand that Liquid Galaxy is a web first impressive platform. It is not just about visualization anymore. At its core, Liquid Galaxy is designed to work with modern web technologies, making the front end a central part of the entire experience. Second, we show the progressive web app from the foundation of front end development for the Liquid Galaxy. PWA allow developer to build application using a standard web app technologies, deploy them easily, and scale them across the multiple screens and devices. They provide flexibility of a web along with the experience of native applications. Third, we explore how Project Fuku bring a native power to the web. Project Fugu allow web applications to access system features safely, interact with devices, and perform background operations. This make PWA powerful enough for real-world impressive use case like Liquid Galaxy. Fourth, we looked at the Go Web Store, which enable easy distribution and discovery. The Go Web Store act as a central app catalog, community-driven platform, a clean distribution layer for front-end applications. It removes the complexity of deployment and maintenance, making the ecosystem organized and scalable. When we put all these pieces together, Liquid Galaxy, PWA's Project Fugu, and Go Web Store, we get a complete front-end ecosystem designed especially for the immersive system. This ecosystem is modern, scalable, and open source friendly and ready for the future growth. Thank you everyone for your time and attention.